Hi everyone, the topic for this video is solving quadratic equations by square roots. Now one question you might ask is why do we need a different method to solve quadratic equations? We've already learned one, we've learned how to solve by factoring. Well, think about expressions like x squared plus 5x plus 5, and let's say that this was equal to 0, and we tried to solve this by factoring. This is one of the examples that we can see actually can't be factored. So if you try one of your factoring rules, all right, or the one that we talked about previously, all right, multiply a times c, that's 5, and then b is also 5. So when you look for two numbers that multiply to be 5 and add to be 5, we don't have any integers that work. All right, so that's one example. We can't solve some quadratic equations by factoring. Here's another one. This one actually can be factored. So if this was equal to 0, we could solve by factoring, but this looks like a pain to try to do. These coefficients are way too large. I don't know about you, but I don't want to try to find some numbers that will work. So here's the second option, solving by square roots. Here's a very simple quadratic equation, and if we look at this, I think we can tell just by inspection what the solutions could be for x. All right, so really we're asking what number squared equals 4, and there are two options. It could be 2 or it could be -2. So here's the gist. When we want to solve by square roots, we'll take something that's squared like this, x squared equals 4, and a square and a square root are inverse operations. They'll undo each other. All right, so if I square root x squared, I know that the square root of something squared is whatever that number is. Okay, so that's going to give me x. Just like if we had the square root of 9, that's the square root of 3 squared, and I know the square root of 9 is 3. Okay. Then on the right-hand side, we also square root that. Okay, so do the same thing to both sides of the equation, and you end up with x equals 2. Now, if you try this on a calculator, or if you're just thinking about the square root of 4, your calculator will only give you what's called the principal root, or in other words, the positive answer. But for equations, we can see from over here, we actually have two answers, and so just so we don't lose that second answer, anytime you square root something in solving an equation like this, you just put a plus or minus sign in front of whatever number you get. Here's a second example. X squared plus 2x plus 3 equals 0. Again, this one can be solved by square roots, but it might not be apparent right now why that's the case. So if you tried to square root this right now, all right, well, we can't actually distribute this square root, so we can't do something like, okay, well, the square root of x squared is x, and then, all right, I've got this piece, square root of 2x plus 3 equals 0. Okay, so that's not allowed. So our goal here in order to solve by square roots, we just need to rewrite this equation in the format where we have something squared equals a number, and that way we can square root and end up with an expression that doesn't have this square. All right, so in other words, we're just trying to rewrite the equation so that everything on the left-hand side is squared, so that when I square root it, that will go away. So you've already learned how to do this, and basically what we want to do is rewrite a quadratic equation in this form. And do you remember what this is called? This is vertex form. Right, so we talked about for functions, this is a nice form because you can see the vertex, and then it's easy to graph from this form. Another advantage is that this form of the equation allows us to solve using square roots. So here's how we'll do this. First, we will subtract k, okay, and then divide by a, and then that gives this expression, okay, on the left. Then we can square root both sides, And since everything on the left was squared, then that square will cancel. Okay, we put in a plus or minus sign. And then finally we add h to get x by itself. And then the very last step is to simplify this square root if possible. Alright, so that's the gist of where we're going, and then let's look at some specific examples so you can see how this works. Alright, here's one that's already in vertex form. So here, what we need to do is just follow that process on the previous page. All right, so first we add 7 to both sides. Okay, and then get 4 times x minus 5 squared equals 7. Then divide by 4. And I'm going to leave this as a fraction. I would suggest that you do that because it's easier to deal with square roots of fractions than it is square roots of decimals. Okay, next square root both sides, and then right away I like to put in a plus or minus sign so that we don't lose that second solution, the one that's negative. Alright, so on the left, the square and the square root cancel, and we have x minus 5, and on the right we have plus or minus square root of 7/4. Okay. Then we add 5 to both sides, and this gets written out front of the square root. If you write it at the end here, it's not wrong, but it is sometimes confusing, especially if by accident you draw your square root sign a little too long, then it could be unclear if the 5 is in or outside of the square root. So that's why we usually write that in front. Alright, so 5 plus or minus square root 7/4. And then finally we need to simplify the square root. So you may remember that there are 3 things that you look for simplifying square roots. And one of them is that we don't like fractions inside of square roots. So I'm going to rewrite that as square root 7 over square root 4. Okay, and then I know that the square root of 4 is 2, so we end up with 5 plus square root of 7 over 2. Okay, so you can see here, this is the solution, actually 2 solutions to the equation. All right, so we have one that's 5 plus square root of 7 over 2. 5 plus square root 7 over 2. And then the second solution is 5 minus square root 7 over 2. All right. So this is interesting because I think up until this point we've only dealt with solutions that were either fractions or integers. And here we have our first example of solutions that have square roots in them. So we can actually solve equations that have irrational solutions, we just can't do it by factoring. Okay, let's try another one. This one, I don't know if you can see that this is in vertex form. It looks a little bit different, but since there's nothing with the x squared, it's kind of like x minus 0 squared. Minus 25 equals 0. So this is in the correct form that we would like it to be in. Another clue, just look and see if you have an x term, and if you don't, but you do have this x squared, then you're good to go. Alright, so we do the same thing, we're just trying to get the part that's squared by itself, and then we can square root it to get rid of the exponent. Alright, so add 25 to both sides, and that's 9x squared equals 25. Then divide by 9, and get x squared equals 25 over 9. Okay, and then square root both sides. And right away put in a plus or minus sign so that you get both answers when you do the square root. Alright, square root of x squared is x. And then over here we have plus or minus, and we actually can square root this entire fraction. So remember, you can square root the numerator and square root the denominator. So square root of 25 is 5, and square root of 9 is 3. So the two solutions are 5/3 and -5/3. Okay? Now this one, anytime you get an answer that's a fraction or an integer, that means that we could have also solved this by factoring. So you might be interested, go back, try this a second way, see if you can solve by factoring and make sure you get the same two solutions. Okay, in the next video we'll talk about just a few more examples of what do we do when we have a quadratic equation that's not already in vertex form. All right, so we'll stop there and try some examples on your own from the textbook if you need to see a few more that look like the ones that we just did. All right, thanks for watching.